So the next two questions that we have, that is question number 11 and question number 12, these are based on hypergeometric distribution. So we will be seeing what hypergeometric distribution exactly is. See, when we were doing binomial distribution, we saw that each experimental run, that is each sample space, can have only two outcomes. What can be that outcome? That can be either a success or that can be a failure, right? But at the same time, in case of binomial distribution, each experimental run is an independent event. This is what? This is an independent event. When I say it is an independent event, what does it mean? That the outcome of one experimental run does not depend on the second experimental run, right? Means these experimental runs are not dependent on each other. See, for example, if I have one coin, this is my coin number one, this is my coin number two. Now, the result of flipping this coin, see, I am flipping both the coins. Now, if I get heads over here or if I get tails over here, this result has no effect on this now. First coin, if it gets head, how is that first coin going to affect the second coin? So flipping of these two coins is completely unrelated to each other. That is why these experimental runs are what? These experimental runs are independent of each other. Correct. But now imagine that I have a deck of cards, right? So if I have a deck of cards, in that cards there are 52 cards. Now these 52 cards are divided into 26 red and 26 black cards, right? Now if I want to draw two red cards, right? So I want to draw two red cards. Now, when I draw the first card, after that, what is the probability of getting a red card in the second try? See, when there are total 52 cards, initially there are 52 cards, there are 26 red and 26 black. Now what I am doing, what kind of card do I want? I want a red card. So in the first case, what is the chances of getting a red card? Chances of getting a red card is 26 out of 52, right? So this is going to be the first card that I will get. Now to find out the second card, what I will have to do? I will have to know what was the card that was drawn first. Right? There is no replacement. Once I have drawn the card, I am not putting it back into the deck. Okay? I have removed that card. So now there are only 51 cards. But what should be the numerator? Should it be 25 or 26? It depends on what the first card was. If the first card was red, now there are only 25 red cards left. So here it will be 25. But if the first card was black, there are still 26 cards inside this. So then it will be 26. Thus, this number is not known to us. We cannot write this number because the outcome of the second experimental run is dependent on the first experimental run. Right? What card I got out in the first time, it will affect the output of my second experimental run. That is why in this case we cannot use binomial distribution. Why? Even though there are only two outcomes, red and black, we cannot use binomial distribution because these events are not independent of each other. The first experimental run is going to have an effect on the second experimental run, right? That is why whenever you have such kind of an event in which there are only two outcomes but the experimental runs are dependent on each other, we can use something which is known as hypergeometric distribution. Okay, it can also be used in other kind where there are more than two events, but we will limit ourselves to only two types right now. Okay, it can be used in which the number of results is more than two also. Okay, the probabilities are more than two also, but currently we will limit ourselves to only two outcomes, right? So how does a hypergeometric distribution work? What is the formula? So there is one important formula which you have to remember for hypergeometric distribution. That formula goes like this: probability of x equal to x is equal to c. In case of hypergeometric distribution, there are two things. There is population also and there is sample also. Okay, in hypergeometric distribution. So in case of hypergeometric distribution, probability of x equal to x, we write it as ACX n minus ACX divided by NCN, where what is all this? First of all, what is capital N? Capital N is the population. Capital N is the population. Small n is what? Small n is your sample. Small n is your sample. Then what is A and what is X? A is the number of items या फिर number of sample space, size of sample space of population that satisfies, sorry, of population, not sample, that satisfies requirement. Okay, you will understand this question when we solve one question. You'll understand all these terms. And small x is what? Number of items of sample that satisfy requirement. Okay, just remember these terms. We will see one sum. After that, you will understand what each and every term is. Right? So let us look at the first sum. You will look at question number 11. See, what have they given us in question number 11? A cricket coach has 20-player team consisting of 11 batsmen, 7 bowler and 2 wicket keepers. So what is the total population? What is the total size of the team? The total size of the team is 20. So population is what? Population is 20. After inspecting the pitch, he decided to field 5 bowlers for the match. If the coach selects the team randomly, what is the probability of selecting a team with exactly 5 bowlers? Right? And there are 11 players in a cricket team. Right? So what is the question that he has given us? He has told us that there are total 20 players. Out of those 20 players, he wants to select 11 players for the team. Out of these 11 players, 5 should be bowlers. And what is the total number of bowlers that he has in his 20 players? Out of 20 players, 7 are bowlers. Right? Out of the population, 7 satisfy our condition. Right? So what is the condition that we are interested in? What is our requirement? Our requirement is bowlers. What is the population? Population is all the players that are available to the coach, which is how much? 20. Out of that, how many players are required in our team? Only 11 players are required in our team, right? Number of items of population that satisfy the requirement. What is our requirement? We need bowlers, no? So how many bowlers are there in the team, in the entire sample, in the entire population? How many bowlers are there in the entire population? In the entire population, there are 7 bowlers. And number of items of sample that satisfy requirement, how many bowlers are required in the playing 11? Only 5 bowlers are required in the playing 11. So what is going to be your probability? Probability of there being 5 bowlers in the team is what? First of all, there are total how many bowlers in the 20-man team? There are 7 bowlers. Out of which how many we need? We need 5. What is the number of non-bowlers, right? So see over here, look at this formula. Our capital N is 20, our small n is 11. Capital N is what? It is our population, all the players that have been selected. Out of that, what is our sample? It is 11. 11 is what? These are the number of players who are actually going to play the match, other are going to be extra. There are total 7 bowlers in the team, but out of those 7 bowlers, we need only 5 bowlers over here. Therefore, capital A is 7 and small x is 5. So we write 7c5, then we write 20 minus 7 c. Sorry, over here it shouldn't be x. I am very sorry. It should be n minus x. Okay, I am sorry. It shouldn't be x. It should be n minus x. It should be 11 minus 5 divided by 20C11. So it means what? Out of 7 bowlers, we need 5 bowlers. If there are 7 bowlers, others are what? Batsmen and wicket keepers. So other players are 13. Out of 13, we need to select 6 players divided by 20C11. So whatever is this is going to be the answer of probability of randomly selecting a team with 5 bowlers. Okay, so I will just put it in the calculator. 7C5 multiplied by 13C6 divided by 20C11. Okay, and the answer comes out to 0.2146. 0.2146, which is what? Which is 21.46%. So there is 21.46% chance that he will select a team in which there are 5 bowlers. Okay, so that is your final answer. So we will solve another sum like this. Before solving, we will first again write the formula. Probability of x is equal to x is equal to what? First of all, sorry, probability of x is equal to x. ACX n minus a c n minus x upon capital NCN. Right? This is our formula. So what is the next question? We will see. A factory wishes to appoint a new 5-member welfare committee. So our committee requires how many members? 5 members only. So that is going to be what? That is going to be our small n to oversee the daily workings of the factory. The shortlisted candidates are as follows. Workers 7, managers 3 and accountants 2. So there are how many? There are total 12 people in the office. Okay, out of those 12 people, we need only 5 members in the committee, right? So what is going to be our population? Our population is going to be 12 because there are 12 members in the company. Out of those 12 members, how many members do we need in our committee? We need only 5 members. So our sample space is going to be 5. What is the requirement that they have told us? What is the probability that the selected committee will contain at least one accountant? There should be at least one accountant. So there can be one accountant or two accountants. See, there are only two accountants, na? But there should be at least one accountant. So one accountant is also allowed, two accountants is also allowed. So for P, at least one accountant, the probability of there being at least one accountant, we will have to do probability of there being one accountant plus probability of there being two accountant, right? This is the addition that we will have to do. So we can find out probability of there being one accountant. What is the total number of accountants? Total number of accountants is 2. Once we need one accountant, once we need two accountants. So we will do these calculations. Probability of x is equal to 1. There are two accountants out of which we need one accountant. First I am doing this calculation. Then in the committee, in the population, there are total 12 people. So 10 people remaining, and in our committee we require 5 members, out of which one is an accountant. So 4 remaining divided by 12C5. Similarly, probability of there being two accountants is what? 2C2 into 10C3 divided by 12C5. Right? So we can find out this value. 2C1 into 10C4 divided by 12C5. So the first part of this is 0.5303, and then for this calculation we have 10C3 and 2C2, and this comes out to be 0.1515, right? So if there is, what is the probability of there being one accountant? Probability of there being one accountant is 0.53. Probability of there being two accountants is what? It is 0.15. 0.15. Okay, so if we do addition, right, 6, 0.6818. The probability of at least one accountant is what? Probability of at least one accountant is 0.6818, which translates to 68.18%. Right? So this is what? This is known as hypergeometric distribution. Hypergeometric distribution is used when events are dependent on each other. That is, the events are not independent of each other. For example, taking cards out of a deck without replacement. Okay, so these were question numbers 11 and 12.